So just a reminder, this is the second part in this short series of webinars on designing right end trials. Last week, we talked about deciding on the objectives for trials. And I made the point that all of the design is driven by the objectives. And so it's really important to have the objectives clear, unambiguous, and really right and relevant to your project. And very often when we have trouble designing an experiment, it turns out to be because there's something unclear or contradictory in the way the objectives have been written down. That's why they're so important. So I'd suggested that you send to us the objectives that you'd planned, that you defined for your coming trials, so that we could have a look at them. I didn't get any of those. If I'd had those, what we would have done now is review them and thought about really three questions. The first one is, are the objectives trying to do something that's really useful? And because we're working within FRNs, Pharma Research Networks, then the objectives of the trial should be useful to everybody in the network or everybody involved in the trial, not just to some people. In other words, it should be relevant to the farmers, they should be relevant to the researchers as well. The second thing we would look at is whether it's really practical. In other words, can you envisage a trial which would actually allow you to achieve these objectives? If the objectives are too ambitious, it's never possible to meet them with a trial. So we should be evaluating the objectives against whether they're practical. And the third thing we need to check is whether the objectives are consistent with being met within a single activity. And I put that down because it's quite common that we write down two objectives which are both useful, they're both practical, but they're not feasible to do them within one trial. For example, if one objective is to get very good data about growth and yield and how it responds to soil fertility, for example, and another objective is to get farmers' assessments and farmers' opinions about something, it might not be practical to do both those in the same trial, because the first objective, getting good data on yield, requires you to have quite a lot of control over what's done. And the second objective of getting farmers' opinions on a technology usually requires them to have a lot of freedom in how they use it and how they try it. And so those two objectives might not be consistent with each other. They're both good objectives, but if you had those two objectives, you might have to do two separate trials to meet them both. So those are the core questions which you should be asking yourselves about the objectives that you've set. The first point is just one that I know you're aware of, but I think it's worth remembering. Every experiment we do is about comparison. Those objectives we set always can be met by comparing things. So I've given some examples, comparing current practice with a new practice, or comparing different varieties, comparing without input to with some input, comparing different levels of input like fertilizer. Right? All these are comparisons, and the essence of experiment is that we compare two or more things, and those things that we're comparing are these, in our case, they're options for farmers. Now, and I hope you understand by now, whenever I say options for farmers, I just think of things that farmers can do differently. Different practices, different varieties, different level of inputs, etc. Right? So in experiments, we're always comparing. Now, there are four ways in which we make comparisons, and we do all of these things, right? And I'm just going to quickly summarize these, because they're really behind why we do field experiments the way we do them. So I'm going to describe four different approaches, and I've given a very simple example of each one, but they can be adapted to make comparisons in many different contexts, to study study option by context interaction, more complex objectives. Okay, these four approaches are, each one is used sometimes. Okay, they're not that three of them are wrong and one of them is right. They're all used sometimes. I've listed advantages and disadvantages of each, but there are many more advantages and disadvantages. So in that column of the table, these are just examples, but there are more things that we could list there. And the way I've described these, I've just described them for sort of comparing two options, which I've called new and current. But it could be, these could be two varieties. It could be anything else. And exactly the same points apply if there are more than two, rather than just two. Okay, so for the first one, the first approach, remember we're trying to compare something new with the old practice or the current practice. And the first approach is just for several farmers try the new one. That's what we call the intuitive experiment. And what happens then is they're comparing the performance of the new one with what they think would have happened if they'd used the current practice. But they don't actually do the current practice. Right? Now, if you think about it, that's a sort of experiment which we do every day, all the time. All the time, we're doing something differently. We're doing something, and we're just intuitively comparing it with what we guess would have happened if we'd done something different. So, and farmers do that. They just decide, this year I'm going to try something else. I'm going to try planting a bit later. I'm going to try planting at a higher density. I'm going to plan my field in a different direction. There's all sorts of things they do, and they try and assess whether it's any good by comparing with what they think would have happened if they'd done it the old way. And these sorts of investigations are done because they're easy. I said minimum disturbance. That means you don't have to think hard about them. The problem when we're trying to do research is that they're subject to a lot of bias and uncertainty, because those guesses as to what might have happened if we'd done the other are often flawed. We're often actually not very good at predicting what would have happened if we'd done something differently. Okay. So those are sort of everyday sorts of investigations, but when we're doing research, we try and do them a bit better than that. The second set here in the second row, this is where you find some farmers that use the new practice, and you find other farmers using the current practice. And you try and compare those two groups of farmers. And that's what some people call a natural experiment. And it's actually the sort of thing we do every time we do a survey. Whenever you do a survey and you end up comparing groups of farmers, you're doing something like this. And again, it's easy because you're just observing what farmers are doing. But in terms of understanding the difference between these two options, it has a problem, because there might be differences between these two groups of farmers other than just which of these two options they use. So we have a problem with what's called confounding. But those sorts of natural experiments are actually what we're doing every time we do a survey and observe what people are just doing out there when we don't set up an experiment. A third way is you find a group of farmers and you randomly assign some of the farmers to try the new method and some to try the current method. And you again compare those two groups of farmers. And that has the advantage of the previous, my previous design of not having the confounding. If your sample is large enough, then the random allocation removes the confounding. But there are two big problems with this design. One is that farmers may not agree. They don't like to be randomly put in a group and told what to do. Okay. And the second is that the data that you end up with will be very variable because farms and farmers tend to be so different from each other. And so we come to the fourth type of design, the within farm experiment, where you find your group of farmers who want to take part, and each of those farmers tries both the new one and the current one. Okay? That gives you good precision. It gives you good information, both for researchers over over the whole population, but it also means individual farmers have good information for themselves as well. Okay? The downside is that you have all the task of setting up this trial so that people do things in the same way, in a comparable way. But I just wanted to highlight that this last style here, this is what we normally think of when we think about designing an experiment. But each of the others does come up sometimes. But for now, for the rest of this talk, we're just talking about these sorts of comparisons within farm experiments. And to design those, the way I think about it is to, first of all, look at the core items or core elements of the experiment that we need to get right. And I'm going to list those in a minute. And then think about how we're going to define each of those core elements. And that how we define them is going to depend on the objectives, on the situation, on the role of farmers. I've said there will be a few more core elements that we add next week, but for the moment, these are the ones that we need to think about. All right? We've already defined the objectives, and now we've got to think about the treatments or options. We've got to think about the sites or locations. We've got to think about the participants, the plots, experimental plots or experimental units, whether and how we do randomization, what we mean by replicates and how many replicates we have, what we're going to do, if anything, about controlling variation, and how the crop on the plots is going to be managed. So what I'm going to do now is I just point out the sort of typical, for typical on-farm trials, what each of these might look like, and try and define the principle on which that is based. And then on the next slides, I'm going to show how those get modified. One, when we're trying to involve farmers more in the design, and secondly, when we're having a large N trials. Right? So that's the plan. So in terms of treatments, you're familiar with that. You know, we might have, for just as an example, 6 new varieties plus a local Czech variety, or we might have some sort of factorial arrangement like 2 levels of fertilizer and times 3 densities of planting. And the principle here is the treatments are determined by the comparisons you need to meet the objectives. So you should be able to read the objectives, and from the objectives, write down the treatments or options that are going to be compared. When we're talking about the sites or locations for the trials, then sometimes people will say, all right, I'm going to have one in a wetter zone and one in a drier zone or something like that. Those locations, the principle is the locations are chosen to represent what you're interested in. And again, if your objectives included comparing different contexts, then those have to be represented by the different locations or sites. When we talk about location, it's not just the site, the part of the country where you do it. There's also a question often about location within a farm or the niche within a farm. The fields that your farmers have are often very heterogeneous. We know, for example, that the fields close to the homestead are different from those from the more distant ones. There might be fields which have trees in them and fields which don't have trees in them. There are those which are on shallower soil and those which are on deeper soil. Each of those sorts of things might also determine the location, be part of your choice of location. And they should be determined by the objectives. The third thing, these are trials with farmers, and so we have to think about who are the participants. Typically, they are volunteers. You can't make anybody take part in a trial, so farmers participating in a trial are always volunteers in some sense. And the principle is, yes, you need farmers who are willing, keen to take part, and to, in some way, represent that community. When we define the plots or experimental units, typically these are small areas of land. Maybe for a variety trial, you might have a 5 by 3 meter strip. If you're doing something, some sort of agronomic trial, then maybe you need a larger area, like 20 by 20. And these, in typical trials, these are measured and laid out by technicians or field workers. The principle is that the plot should be a plot of land which is large enough to behave like a whole field. In other words, what you can measure, or the way the crop performs in the plot should, even though it's a small plot, it should be the same as if the whole field was full of the same thing. Okay, so a very small plot is very influenced by the edges, and that doesn't meet that criteria. So the plots need to be large enough to behave as they would behave if the whole field was the same. But they've got to be small enough to manage and measure. Random allocation. Okay, the ideal or typical is we do random allocation of treatments to plots. And the principle is that each plot should have the same chance of getting any treatment, and that's to avoid bias. If you don't do that, there is a possibility that some treatments will consistently go on good plots and some treatments will consistently go on bad plots. In terms of replication, then for on-farm trials, it's quite usual that we have 1 or 2 replicates per farm. And the idea is that repeated plots of the same treatment show the size of non-treatment variation. We take steps to control variation. So the idea is that all plots, typically we try and make sure that all plots are homogeneous in terms of soil. And the principle is to minimize variation by making everything homogeneous. You wouldn't use sort of odd plots which are odd, not typical. You wouldn't include in an experiment. And in terms of management, typically we say the management, things like date of planting, whether fertilizer or manure is used, and so on, that those things should be the same on all the plots on all the farms. And the principle usually is use best practice and manage all the treatments in the same way. Now, those are things that you're familiar with. If you've done any on-farm trials, then you should be familiar with those. So what the next slide says is, if we're going to try and have farmers more engaged in the design of these trials, how might these elements change? So in terms of treatment, we've already talked about farmers' choice of the treatments. So rather than every farmer having exactly the same set of treatments or options on their farm, there are reasons, and we've already discussed those, why you could have farmers choosing at least some of the treatments that they include. The principle is that you don't have to have every treatment being exactly the same on every farm. Sometimes, though, you want to apply some rules. So a rule might be, if you're going to take part in this trial, then you can pick new varieties to test, but we'd like everybody to pick 2 new varieties. We'd also like everybody to include at least 1 local variety. So we're not going to tell you which local variety, and we're not going to tell you which new variety, but we'd like everybody to have at least 2 new ones and at least 1 local one. That would be an example where there's choice, but there's some rules as well. In terms of sites, you really need to make sure that you are, first of all, the sites for the experiments, of course, they need to represent a project area and a range of contexts you're trying to study. In terms of the within farm niche, I think the principle should be farmers put the experiment in the location on their farm where they might use that technology afterwards. So if they grow their cowpeas in the parkland under trees, that's where they should do the cowpea experiment. And if they grow their cowpeas in the field next to the homestead, that's where they should do their experiment. So they should make sure that the niche used for the experiment actually is the niche in which they would use the technology. And that might be different for different farmers. And that's the important point. It doesn't have to be the same for everybody. It's more important that it represents what farmers are actually going to do than that it's the same for everybody. When it comes to participants, most of the projects now have a group of project participants or members. For example, in Fumogaskia, there are members of Fumogaskia who want to take part in the trials. So that becomes the criteria, that these are, you're not going to just go out and randomly select farmers again. You're going to have the people who you are working with are the participants in the trial. For experimental plots, again, I think you don't have to be really rigid on what the plot size and shape is. You can let farmers have some choice in that, but you might want to set some rules again so that there are sensible, practical minimum sizes, because if it's too small, you can't really understand how the option is working, and maximum, because if it's too big, then, well, first of all, farmers won't want to risk a larger area under a new practice. And if you're supplying seed or any other inputs, then you can't provide it for a very large area. But we don't have to have exactly the same size for every farmer. In terms of randomization, I found that farmers understand the idea of randomizing and the reasons for it if you explain. So rather than just saying it's randomized or just telling them a random allocation, explain why random is a good idea and they will understand that. And then you can do the randomization in an open way. I mean, you can actually randomize there in the field by picking treatment numbers from a box, from a hat, so that everybody can see what it means to be random, and that works nicely. In terms of replicates, in most cases, I would recommend just 1 replicate per farm. I've often seen farmers think having several replicates on their own farm is a bit of a waste of time. They'd rather have a larger plot of each treatment than to have 2 replicates. And for farmers, often the replication, that is understanding what happens, what the variability might be, comes from seeing what their neighbors are doing as well. For controlling variation, when we're doing trials with farmers, we just have to accept that the variation between farmers is there. Right? Within each farm, you need to make sure you're comparing like with like, and farmers understand that principle. If you explain it, they understand that principle very well. But the fact that some farmers plant earlier than others, or some farmers use manure and some don't, some farmers weed it more carefully than other farmers do. That's part of the natural variation which you have to take, which is going to be part of trials in which farmers are involved. And next week, when we talk about measurement, I'll talk about how we should measure those things. But don't think that you need to control them and have everybody doing exactly the same thing on the same day. And when we think about moving to a large N trial, this is a trial where, based on the objectives, we decided that the number of farmers involved is going to get bigger than typical size. So we might be talking about several hundred rather than tens of farmers. There are a few more things which we might want to do differently. Again, you should be, when the size is growing, the participants and the sites should still represent what you're interested in. They need to sample the social and the biophysical context that you're interested in. When it comes to experimental plots, then one of the principles of large N trials is that farmers do more of the work. You can't do a large N trial with hundreds of farmers if your technicians have to go and measure and lay out every experimental plot. That's not feasible. Farmers have to be able to lay out experimental plots themselves after they've had some instruction. And that means the design, the plot size and shape, etc., needs to be simple, and it needs to be as close to what farmers are doing anyway. And again, for randomization, farmers being trained why it matters and how to do it, but then leaving them to do the randomization when they plant, I think is necessary. We talked last week about the number of farmers that need to be involved in large N trials, and just as a rough guide, I'm saying if you're wanting to compare different contexts, then a minimum of about 10 per context often seems to be about right. There are all sorts of reasons why you might want more, you might want less, but I think that's a reasonable, very rough guide to the numbers that might be involved. For controlling variation, I said you can't control the variation. You can't go around and inspect every plot, every farmer's field, and make sure that it's homogeneous. Instead, you need to make sure that farmers understand the principle of comparing like with like, and trust them to lay out the trial in a way which is okay. And the same when it comes to management. Things like planting date and use of manure. Farmers are not all going to do the same, but if they understand why they should be doing, as far as possible, the same thing for different treatments, then that's what you need to do. Okay, so this was then just referring to the how big N needs to be, and I went through this calculation in some detail last week, and that's just a reminder of it. So finally, this PowerPoint is available to you. I think Dave has sent, or he will send you the link to the PowerPoint, and in there you see this link to some more YouTube videos. These are YouTube videos that we made a while ago about designing trials of farmers. So they go through more aspects of both the principles, concepts of trials with farmers, and also some of the practicalities of trials with farmers. And if you want more information about this, then I think you should have a look at those. So again, what I would suggest is that between now and next Thursday, you try and write down your decisions about these elements of the design and send them to us, and we can have a look at them and discuss them before the presentation next Friday. And the presentation next Friday is going to be about measurement, what to measure and how to measure it, and in particular, how the things that the choices about measurement will be modified by the fact that we are trying to involve farmers and we're moving towards large N designs.